So welcome back guys, and today we are going to start the essay series from scratch, and I'll make sure that we go to a level where we can crack any fan interview or any man interview that we want to. So let's start. So today we'll understand what a programming language actually is. So programming language is a language in which you are writing your code in English or a high level language, and then that language is converted into the machine code or the low level language, and it is given to the hardware for execution. So what happens under the hood is that your English language is being converted into zero and ones, which the hardware actually understands, and this work is done by a compiler or the interpreter. So compiler is a piece of software that is going to compile the whole of your code into a bytecode in one go, and then it will start executing or running. Whereas interpreter, which is commonly used in Python language, it does what it does is it takes one line of your code, it compiles it, and then runs it, and then another line of code compiles it and runs it. So that is actually how a programming language works under the hood. We have basically three types of programming languages. One is our procedural language. Here, the flow of control in your program is in the form of a procedure. For example, firstly, this thing should execute, then the other thing should execute, and then only the third thing should execute. So there is a sequence. For example, take input 1, take input 2, calculate sum. And if you have a multiplication, so you will have to make it a procedure that after sum, only then the multiplication will happen. Before the sum multiplication cannot happen. That is what procedural language means. Then comes our functional language. Here we are using pure functions to actually control the flow in our program. It is basically used in Java and similar languages. So here we can make a function sum, we can make a function product. So we can take first input, the second input, and then we can call product or sum, whichever we need as a function, and the work will be done. And then we have object oriented language. So object oriented language is a language where we have some functions, some objects, some classes, and all of it mixes up into something that we can write as a code and get the desired output. So let's deep more into the object oriented thing, because it is something that you will have to see in your journey. So it basically has two things. One is class and one is object. Now what is a class? So you can understand class as a architectural blueprint of a building. For example, the building should have two rooms. The building should have a bathroom and the building should have a lift. Now, what is the object? Object is the actual building that will be made. So in object, you will decide whether in the two rooms that we have, we'll have tiles or we'll have marbles or we'll have Italian wood. So all of these three things will make three different buildings, which are our actual objects. Now, why do we use OOPS? We use OOPS because it brings modularity in our code. So, what is modularity? Modularity is dividing something bigger into smaller chunks so that we can just use that smaller chunk and we can just replace it. You can understand it in a better way by the example of a car. So, you have a car, it has different pieces of it which can be replaced. For example, if your engine is gone, you can just replace the engine. If it's the windshield, you can just get a new windshield and place it in the original car. So that is what modularity is. And now you can understand why it is actually important, because nobody wants to replace the whole car if some part is only damaged. We have different languages, and this is exactly where most of the developers like us are stuck, whether we should go with C++ or Java or Python. So it is something that you can understand, but for a beginner, I'll suggest you should either go with C++ or with Java. And if you are going into AI/ML, then you can go with Python. But we will continue with this course in Java. And Java is both a procedural and a object-oriented language. We have C++, which is procedural and functional language, and Python can be procedural, it is functional, and it is object-oriented, all of the things. Then we have some more things in our languages, that is static typing and dynamic typing. Now, when you will learn more in Java, you will see that we are always defining the data type of the variables that we are making. For example, here you can see int a is equals to 10. So this is called as static typing. We are actually telling the compiler that a is a variable which can hold only a value of integer type. So it will be checked at compile time and it will then be converted to the bytecode and given to the hardware for processing. Now here you have more control and the runtime crashes are less, so you can exactly see where the error is and why the error is. But here you don't have the flexibility of just using one variable in different ways, which you sometimes want to have. Then we have dynamic typing. Dynamic typing में क्या होता है कि we have a equals 10 and then we can just do a equals Atul. Now 10 is integer, Atul is string. So we can just change the date types as per what we want. But here comes a problem because we are not going to have error at compile time, but at runtime we might get into errors. Now, in programming languages like Python and Flutter, actually Dart, we have dynamic typing. So you can just write fast in there. It is highly flexible, but you will not be able to just track down if a single error comes at runtime very easily compared to a compile time error. Now we have memory architecture. We now know what a programming language is and how it is working under the hood. The next thing that we need to know is key how actually the memory is being allocated in our system for any programming language. So we have two things in our memory. So whenever we run a program, we have a stack and we have a heap. So all the functions that we are calling and all the variables that we are making, they are being stored in the stack, and the actual memory that we require, it or the actual object that we require, it is stored in another memory called as heap. Now these are just partitions inside our original memory, but so that we can have a modular approach, we are storing variables in the stack and the actual memory in the heap. For example, there is a physical memory instance in our heap, and now we can have multiple variables in our stack which are referencing to that memory only. For example, we have Kunal, we have son, and we have baby. There is this person whose name is Kunal. He might be a son of someone, he might be a baby of someone. But just imagine that you are going to ask Kunal to pay the bill. So the bill, when it will be paid by the Kunal, the account is going to be depleted of that same person, whether it is Kunal or son or baby, because they are all referencing to that person in the heap. Then we have arrays. So if you will see that array, there is 1359, and we can access the heap memory of array by just using the index numbers, which I'll be teaching you further. So a of 0, which is 99, here you can see that we are changing it. So there is one bucket which is A 1359, and then we say B is equals to A. So now both A and B are referencing that array of 1359. Now we are doing A of 0 is equals to 99. Now what happens? That we are saying in the heap, which is being the memory element which is being referenced by A, having index 0 should get updated with the value 99. And when we are printing B, it will print 99 only because both of them were referencing the same object. That is why we have a differentiation of stack and heap when we are working in the programming languages. Now just imagine that A is referencing 10 and now A references 37. So A is no longer referencing 10. Now you think by your own common sense that if A is not referencing 10 and there is no other variable that is referencing 10, so 10 is just a garbage and it should not be present in the memory. Otherwise, it is just taking up more space and is of no use. So what will happen is that our programming language has an automatic garbage collector which collects such kind of garbages from our heap. So 10 will be removed and A will now reference 37 and only 37 will be left in the heap. So that's it for the video. Today we learned about what a programming language is and how it works under the hood and how we do memory management. In the next video, I'll tell you about the flow of control, about pseudocodes and flowcharts. So stay tuned for further updates. Sayonara.